Exploiting Netgear RAX30 router. Team 82 researchers found multiple vulnerabilities in Netgear routers and they were able to chain them to perform a remote code execution in the router. Wow. Let's give this article a look. We will skip the summary part and directly move to the vulnerability section. Netgear Nighthawk RAX30 vulnerability detail. Issue number 1 CVE 2023-27357 Netgear RAX30 get info missing authentication leading to information disclosure vulnerability. One of the few commands that does not require authentication is getinfo. In the get response, we can find details about the device such as the model, serial number and more. Okay, so this looks like a network adjacent attack. An attacker is connected to the Wi-Fi but does not actually have credentials to access the router's admin panel. They have found an endpoint that requires no authentication and it is returning router's details. The sensor mentioned there is not much we can do with this information at this point, but let's keep this information for later. Issue number 2 CVE 2023 Netgear RAX30 SOAP binary stack-based buffer overflow leading to authentication bypass vulnerability. Let me just give you a very surface knowledge about this title. Let's consider this code. There's an array and a scan function that is taking an input. When we run this code, a stack is created. It has a base pointer and a stack pointer. Within this code, there's an array of 6 characters, so 16 byte of memory is provided. We are adding it to the stack. Understand this stack as the place where everything belonging to this program required information is stored. It must hold everything from local variables, registers to return address, and almost everything that you can think of. When we run the program, and let's say we enter the word HELLO, now each characters will be stored in the array in this format. A0 will store H, A1 will store E, and so on. On the stack part, it looks something like this. RBP-6 stack frame offset will store the value H, RBP-5 will store E, and so on. As I said before, a certain memory is assigned to this stack, and stack must hold everything inside it. As an example, the return address is being stored on RBP+8. The problem in this code is scanf has no length limit. Yes, the array says 6 characters, but scanf does not really care about it. Here I can even type HELLOMYNAMEISSPANDAN, and now if we take a look in the stack part, there's not even adequate place for my complete input to store. As a result, my input will start overwriting other data. As an example, the stack frame offset which was holding the return address gets overwritten by my input, meaning the entire program will crash. This is called buffer overflow. One more attack example can be, let's suppose there's a function in the code that has never been called. So an attacker can carefully craft the input payload to specifically change the return address and point it to that function, due to which that uncalled function get triggered. This is also how buffer overflow are exploited. This much knowledge should be enough. Let's go back. Issue number 2 CVE 2023-27368 Netgear RAX30 SOAP served stack-based buffer overflow leading to authentication bypass vulnerability. So here they're going to utilize this same attack to bypass router's authentication. To handle communication, SOAPServe reads the HTTP headers first and then proceeds to praise them using the scanf function to extract HTTP method, path, and protocol version. The code will split the request into 3 parameters, method, path, and protocol. As we can see in the call to MEM set, each parameter's method, path, protocol is expected to be no more than 0x7fc byte long. The server does not check the length of the method, path, and protocol field, meaning we can overflow them and overwrite the data on the stack. Okay, so there's an HTTP request and they found that the request method, path, and request protocol is being extracted and is being praised using the scanf, and there's no character limit. Yes, the parameter is expected to be 0x7fc byte long, but scanf does not really care about it. So they can perform a buffer overflow attack here. Unfortunately, the HTTP receive function over TCP port 5000 limit the size of HTTP headers, thus limiting the amount of data we can overflow. In order to avoid that limitation, we used something a bit different. This looks like a router-specific scenario as we don't have anything such like headers limit on port XYZ in general. Anyway, they are on port 5000 which has a certain header limit which they will need to now bypass. Issue number 3 CVE 2023-27369 Netgear RAX SOAP-served stack-based buffer overflow authentication bypass vulnerability. Why does the title look similar? Anyway, the SOAP-served binary listens for an incoming message on 2 ports, port 5000 and port 5043. Okay, they found another port 5043, which is a SSL port, and I can already guess what's coming next. Different socket read and socket write functions are called depending on the port that the SOAP message was sent to. When reading the SOAP message header, the server reads data from the socket one byte at a time. However, we discovered that in the SSL flow, the read function does not check how many bytes were read, which could lead to buffer overflow. Okay, in port 5000, there's a fread function and there's a limit of 0x800U, which should be near to 2000 bytes, I guess. So buffer overflow isn't possible here. On the other hand, on port 5043, there's a while loop which is reading data one byte at a time and it does not check how much bytes are read, meaning buffer overflow is possible here. I'm kind of curious how they're going to bypass the authentication by this overflow. Anyway, let's move on. Reading unlimited data can result in two issues: stack exhaustion. Sending large buffer can read more than the stack size and crash the server. We already discussed about it. Buffer is of unexpected size. The flow that praises the header expects them to be a certain maximum size limit. We can use this vulnerability to write long buffer on the stack while bypassing the overall buffer size limit. If we use SSL to send the SOAP message, we are not limited in size due to the stack overflow mentioned above, meaning we can overwrite as much as data as we want. Okay, so they are referring to the port 5043, which has no any limit. Bypassing stack canaries. Okay, let me give you some idea about stack canary. Take a look at this assembly code. Here at the beginning, a random value, canary, will be assigned to a specific stack offset. At the very end, before the return function, that stack offset will be checked against the initial canary value. Like if an attacker somehow manages to perform buffer overflow, the overflow will indeed override the canary before overwriting the return function. So the canary is checked before the return function. And if it's not equals to jump not equals to, then the program jumps towards crash function and ends the program. This isn't a foolproof solution to buffer overflow, but still in most cases, it helps you detect it and end the program rather than allowing an attacker to modify the return function. Bypassing stack canaries. Now we understand that the SSCANF vulnerability and can trigger it without any limitation on how much data we can override. We are left with only one issue, the stack canaries. In the recent version of RAX30 router, Netgear started to compile the SOAP binary with the stack protection. These protections make it harder to exploit the stack overflow in our traditional way. Our approach to bypassing the stack canary was to try to somewhat logically bypass it. Stack canaries are set at the beginning of the function that have potential for an overflow but are checked only at the end of the frame. This means that by using scanf overflow, we can override the canary, finish the request handling and response flow, and then we can get to the end of the function where the canary is checked. Okay, so they have given a stack layout. The stack canary is initially set, and then comes the SSL read, where the data is read from the socket that attacker is sending, and then comes the scanf, which praises the request method, path, and protocol into the buffer. And then comes the HTTP request handling, which may include authentication logic, SOAP routing, building responses, etc. And then comes the HTTP response sending. At the end, it checks canary, and if it is changed, the program crashes. They are accepting that the canary will be corrupted and the process will crash at the end, but they are exploiting the fact that there will be some useful work done before the crash, which can be overwritten. Since most of the SOAP command require authentication, we are focused on trying to bypass the authentication flow. The first thing the server checks when authenticating user is whether the request came from the localhost. Okay, look into the code. It says if the request is generated locally, no further authentication is required. Requests coming from localhost do not require authentication. Luckily, we discovered that the socket source IP is stored on the stack in an offset we can overwrite without stack overflow. Okay, so looking at this surfacely, a certain stack offset contains the socket IP, which they will need to modify using this buffer overflow. They will need to carefully craft the payload that replaces the socket IP stack offset to localhost, and doing so will bypass the authentication. Using the stack overflow to override the socket IP to 127.0.0.1, we are able to make the server think the request was generated locally, bypassing authentication and run any SOAP served command. This vulnerability by itself is not enough because we are usually limited to 0x800, 2048 byte, so we changed it with the previous vulnerability over TCP port 5043 SSL, which allowed us to write more data on the stack. The final payload we constructed was: we will directly look at the raw request. They have carefully crafted the path and they were able to change the value of memory address 0x7EFFF510 from their IP to localhost. Using the fake IP, as we can see in the after image above left, we are able to bypass authentication and call any function the SOAP served exposes, as if we are fully authenticated. We decided to call the get config info command, which returns the router's entire router configuration, including the device serial, MAC address, hash password, and much more. This is great. Issue number 4, CVE 2023-27370, using SOAP served auth bypass to reset the admin password. Okay, so now they are trying to reset the password. While setting up the routers, users are required to enter a new unique password and provide security questions and answers that will allow them to restore the password if they forget it. The answer to this question are stored in plain text base64 in the device configuration. In order to reset the password, users need the serial number of the router and answer to the security question. Therefore, by getting the raw configuration using the 3 vulnerability above, an attacker will be able to reset the admin password below. Okay, security questions are stored in plain text and they have the ability to read the raw config file, so they are now able to reset the password. Issue number 5, CVE 2023-27367, authentication bypass to RCE using Magic Telnet and command injection. Since they are able to reset the admin dashboard password, they are authenticated. For those of you who do not know what Magic Telnet is, authenticated admin can send a crafted package to the router which allows them to open Telnet on port 23. Like it's kind of a support or debug backdoor for them. It is not directly a code execution yet, as it does not allow you to run any random command as a root user. They have indeed bypassed it. If you want to know how they did it, I'm giving the link either in the comment or in the description. I'm leaving the RCE chain for you. You should definitely give it a look.
Oh my god, bro. Oh, hell no, man. What the fuck, man?
Anyway, the report was really interesting. I mean, as I said before, it's always interesting to see RCEs from buffer overflow attack. Remote code execution is itself a critical issue. I guess the pre-auth condition here will degrade the severity, but still, this is a great find. All thanks to Team 82 researchers who found this vulnerability and detailed this report. If you love similar report and want such explanations or you are into cybersecurity, follow me for more, hit the subscribe button and see you in the next video.